Well, I finally got a 3D printer, thank the Lord, and my mate picked it up. He paid 20 quid for it. It was broken, and he's repaired it for me, so I gave him 60 quid altogether, 20 quid petrol and 20 quid working. Thank you, Chris. And it didn't have a power supply, so I've had to get this. God. I've had to get this power supply and get the 24 volts, set it with 24 volts on there, and I've had to make a socket, well, get a socket, and oh, has that got a nick in it? Oh, it's got a bloody nick in the wire. Oh dear. What was it saying? So that plugs in alright, and I've got to make something to put the spools on, because I've got a bigger spool from my friend and it won't go in. Oh, it's too big. So we have to make something to fit this on here, Heath Robinson style. So I wanted it in the middle, but if this is coming down here from there, well, it wants to be a bit further in the middle. Oh dear. Oh no, if I put it higher up, it won't matter so much. So we'll carry on. We'll carry on with that. I've got a bit of aluminium bar to use. So I've got some aluminium bar. I think it's a metre, 8mm by metre, but I've cut a bit off the end. And I'm going to put it in here, then bend it around, bend it there and there, work out the distance here, and then bend it so I've got a U shape, and it should sit in here and put the spool on there, hopefully. So I've got this in the middle, measured 35.7 this side, 35.7 that side. So we'll just mark it. I haven't got a felt tip pen. I've got a borrow. It's still working. And we want really, that's the distance we want, but we want it to mark both sides, because we want it to bend before then. Right, let's go in the garage. Right, so that's where the thing wants to come down, but we're going to bend it about there, so it's got a bit of an angle on it. Oh, bugger. One side done. I've just watched a video on YouTube and one man puts a bit of wood on there, and when it burns it's at the right temperature. I don't think I've got it that hot. No, I've not got it that hot. Okay, right, excuse the mess on the house. This is my front room and I live on my own, so there's no one to tell me what to do. Right, there you go. That's it. Perfect. So it fits on, but obviously there's a big gap, and if you're going to have that big gap, I presume it's going to start jumping about. I don't know actually, but I think we're best off making a middle bit for it somehow. That's not too bad, is it? It wobbles a bit, but so do I. Right, so next we're going to have to make a spacer with a diameter like that, but also we've got to make the diameter bigger so it can go over that corner. So it's 8mm at the minute. And then I've got a bit of wood that I stole from work. Let me not tell anybody. And I'm going to cut that out as a round thing, a round shape to fit in there. Plus I'm going to put a slight taper on it. I think, yeah, I'm going to put a slight taper on it so it will press in tight so it don't move, but also have some sort of lip because you've got to pull it off as well, haven't you? That's the future. So if you're wondering why I haven't made one out of the 3D printer, it's because I don't know what I'm doing yet. So I'm going to put it in the middle so I can make an edge. So I've drawn an edge on by hand. Forgot we need to put a hole in the middle, don't we? So we're gonna. So what's that? 1, 2, 3, 4, 5, 6, 7. So there, 3.5. We'll check it the other direction. Oh God! Come on. About there in the middle then. I have to go up to 13mm before I can get around the bar around the corner. Oh God. There you go. Whoa! I've just rough cut it with a saw and used a bit of an angle grinder on it to get some bits off, and I'll put it in the vise, in the lathe now. Well, I've got to put it in the lathe next, but this is the only bolt I can find and it's not very long enough. So I'm going to grip it on there in the lathe and hopefully it won't fly out and kill me. Otherwise we're doing the rest of the video from hospital. So, oh shit, some of it's broke off already, look. Oh bloody hell. Well, this is a metal lathe and we're going to just try it out, see if it works with wood. Well, I thought I'd film the lathe work in case something went wrong, and it did, but the bloody memory card was full up and it stopped filming. Sod's law. So this idea is scrapped. Right then, I've got this might work. I had this wire on it, so I've got to take it off obviously. So it's wider than what I want, so I'm going to cut it down. And then it's got 2 holes, so when we've got it together we can just put 2 bolts through to make it more secure. Right then, I've cut these 2 down into 2 parts. I've got some bolts. This is perfect bolt, that is rubbish. Well, it's not rubbish, but it's loose. So you just put that on there. Can you see that? Yeah, put that on there. And put that on there, obviously. So we'll get the bar we're going to attach it to and put one on first. we'll sort it out. Back in a minute then. Well, that's working. Quite happy with that. That's that bit done. Stable enough. And it can move if it wants to. It won't lock up, will it? No, it will lock up, but it's not going to go to the side, is it? Hopefully not. It's going to stay in the middle. Alright then. Next bit then. Right, I was going to use a standard bed, but I think I'm going to change it to a heated bed. Going to make one as per normal. So I'm going to take this off and weigh it as well to see, make sure the materials I've got are not too heavy. I've ordered a 20mm plate. This is 16 across there roughly. I've ordered a 20, so it'll go a bit wider, and ordered 20mm glass and a 16 by 16 heater, 150 watts, 24 volts. So when that arrives, I'll stick it all together. I'll make a controller for it to control it. I think it'd be a bit too hot, so we'll have to put a controller on it. Just a late night thought. I've got one of these 12 volt car heaters, that 150 watts, that you sit on the your dashboard, and it heats the windscreen up, probably on a diesel. Got it off a Polish man, good friend, and it sits on the windscreen and defrosts the window as you before you get a chance to go down the road. So this might work in the heater, in the printer, 3D printer cabinet to heat it up. So I'll just plug it in and see what the temperature comes out the output. Oh dear, it's a bit noisy. Obviously you get a brand new one. Where's the probe gone? So I'm putting the probe in front of the heater now. Is it working? So that's going up to is 39.4 degrees, so we'll give it up on that there. I was a bit drunk when I thought about it, so oh, 40. So it's up to you with that one. So I'm going to measure the height of the board, the bed, but unfortunately you can't really get in there like this. It's a bit. I can't get to the that bit there, so I'm going to use a ruler across and measure from the top of there. Right. Time it there. 82 virtually. So we'll minus. Now we'll go and measure this bit, which is easy. And that is minus 25. Oh, I haven't zeroed it in, have I? Zero it back. .1, so 79 will be alright then. So now I'll undo all these screws and take it off. I've never took this off before, so we'll see what happens. So, a bit dusty underneath, and then we've got 3 screws coming through there, so when we get the aluminium plate, we'll make a copy of that. Yeah. I'll just check how much the bed weighs, because it feels quite heavy. 49 kilograms. Oh, is that 49 or 400? It can't be 400. Is it? Oh, it is. 492 grams. Well, I've just worked out the weight of the 2 aluminium plates I'm getting to replace this. 2 4mm by 20 by 20 centimeters, and they weigh, with the glass, twice as much as this, 1.2 kilograms. So hopefully it might be alright, but if otherwise I've got to get some thinner aluminium plates or drill loads of holes in it. So next bit then, let's get the electronics controller set up. I've just been to B&Q's and got another one of these handy double gang outside junction boxes. Ideal for an Arduino and the controller, hopefully. It's quite big, the controller is. Let's go and find a controller, a solid state relay. So here's a box of relays. I was thinking I'm going to use this one. I thought this could do 24 volts DC, but no, it looks like it's AC. So these ones, obviously not got too many together. Got single ones, but I think these are 5 volt input, 240. Yeah, I think they're mains again. They're AC. This one is a DC. Then what we've got here then? 5 volts to 5 amps. 5 amps. Yeah, 5 volts to 220 volts DC at 5 amps. That's big enough. We'll probably use this then. DC to DC, solid state relay. Input is 3 to 32 volts, so that's perfect. I mean, let's look at these ones. These ones are DC to DC. That's how many amps these are. Oh, I can't. 2 amps. Oh no, 2 amps is not enough, is it? That would be 24 watts. So what's this one then? 5 amps times 24 volts is, oh my lord, not enough. We might have to run the heater on 12 volts perhaps. Oh bugger. Yeah, sorry, I forgot to mention that the heater's 150 watts. So I don't think this will do it. These are 5 amps each. I wonder if I could put them both together, link them both up, fire them on at the same time. Bit risky, but we don't mind a bit of risk sometimes. Then the temperature probe I'll be using is a DS18B20, and it goes up to 125 degrees, which is not really perfect because I think you like to go a bit hotter, don't you, on some stuff. I'm no expert on 3D printers, I'm just winging it. So we've got the Arduino, the on-offs, and that's it really, I think. Oh, we need a switch to turn a variable switch to adjust the temperature. I'm not going for a screen. Bit solder some connections on, some leads. That was a bit big. It's a bit loose. This one's better. Bit of shrink wrap. So when you've got your Arduino IDE loaded, go to Sketch, go to Include Library, and then you come across Manage Libraries. And it's gone off. I'll do it again. And it's come back on again, and I've searched for the one we want, which is the DS18B20, and it's come up with that one, and that's what you need to press there, and that should be it. And now that library's installed, it's like a driver. It's a bit of software to make the temperature probe run on the Arduino. You also need this library as well, one wire library. So I've got a program sort of in. Whether it works or not, we'll give it a go. Here's the wiring. That should be a red wire, that one. You just got to put the ground to ground, the yellow to yellow, and to here, then a 4.7k resistor to positive, then positive to there, and it should work. Oh, there's the code I finished with. Can you see that? There's a code I finished with, but it's strange. I've took delay out and it's still running really slow. So there's the program, and if I get the look how slow it is. So you're doing just under a second. And there's no delays in the program. I've never seen this before. I don't know what's going on. But it's reading roughly the right temperature, just 1 degree higher than what it should be. Now I need a variable switch to adjust the temperature. And I think you put 5 volts in one side, earth on the other, and then tap the middle off for the voltage. I think that's how it works. We'll find out, won't we? Okay, I was right then. So positive on the bottom, negative on the top, and tap off from the middle to your analog pin. So just put a voltmeter on it, obviously. Just turn it around. So it goes from 5 volts virtually down to 0, so that'll give us a reading on the analog pin. So I've added a bit of code in to read the analog pin, and then print it off in the bottom serial monitor bit, and it's working. Goes from 1023 to 0. So now we've got to convert that, because I think I want the printer starting at 50 degrees, let's say 50 degrees, going up to 100. So we'll put an equation in. So put this equation in, so what it does, I've got another variable, and we're using the variable on there, look, to print it out. So ST equals 50, which is the bottom temperature you want, plus S, which is a variable switch from 0 to 1023. So if you divide that by 4, that should be, oh no, 20. We want to divide by 20, don't we? Oh dear. 20, that should give a range. S should come out from 0 to about 52 or I don't know, 56, perhaps 55. So we'll go from 50 to 105 or 106 degrees on the temperature range, which is ideal because my temperature sensor is 125 degrees. So we'll just try that out. Right, so where we are, I don't know if you can see that, yes. And it seems to be working. So that's on 0 on the variable switch, so I'll turn it up, so that's 50 degrees. So turn it up and it's going right up to 101, which is absolutely perfect. I'm happy again. Might be the lager. So we'll put that into another command. We'll get another command that'll adjust the relay turning on and off. So there you go. I put a statement in there. So an if statement, 2 if statements. So if the temperature is below the set temperature, then the relay will turn on. If its temperature is high above the set temperature, then the relay will turn off. And then it'll print the results out at the bottom here, so we can see at the bottom. So we shall test it by using a lighter. So you'll see that change to a 0 when it goes above 50. Has it got above 50? Oh, it hasn't moved, has it? Come on, go up, yeah, bugger. I don't want to set fire to it. Here we go, there you go, it's turned off. So that's perfect. I'll put my finger on it now to cool it down. It should go back. There you go, so that bit's working alright. Right then, I've had a few beers and I'll try and explain what I mean. If you've got an on-off switch and it comes on at 60, and say it comes on at 60, there's 60 degrees, comes on, it'll heat up, the sensor will read it and turn off and go down again and come up again like that, and you get a waveform in your heat. Someone else called it bang bang, I call it ripples. Anyway, so what I do, I've done it on another project and I've turned it off. So this is 50 degrees. So no, this is 59 degrees. And then you at 59 degrees you turn the heater on for 9 seconds and then turn it off for 1 second. And then at 59.1 turn it on for 8 seconds, turn it off for 2 seconds. As you come up to there, it's on for 10 seconds, 50, oh god, I can't, and it's on for 1 second. Oh, am I talking shite? That's off or completely, and it's on there for 1 second and off for 9 seconds. So as it comes up to 60, or the target temperature, it slowly cools down. So you get rather than getting that, you get it comes up to temperature, it starts to get to 59, and it starts to slow down slightly, and then it should go into a nice thing, and then it should sort of come down a bit more, and it does sort of hover about after a few cycles and steady out. I've had it working, this system. And then you'd obviously adjust your knob to get it to the right position with the temperature gauge that's coming through the post. Laser temperature sensor, which is £8 on eBay. You know, it's late at night and I've got this if command, and I cannot get it right. What's going on? It keeps activating. It shouldn't activate because it's not. I can adjust it now and it won't make any difference. What the hell? This keeps activating all the time. Is it because I've got too many commands behind it? I've done it loads of times before. Oh, I tell you what. So I'll put a rem statement in there, look, get rid of it, and the program works perfectly. So God knows. Right, I finally worked out what I've been doing wrong. I haven't put brackets on the if statements. Can you believe that? So that's what's been causing the trouble. I'll have to edit most of it out because I'm swearing. So I've got, here you can see, if it's above the set temperature, sorry, if it's above the set temperature or equals the set temperature, then it turns the power off to the relay. Get off, bloody fly. Bloody flies. And then if it's 1 centimetre, 1 degree Celsius below the set temperature, it turns the power on just for 2 seconds and then turns it off for 8 seconds. I'm going to lower them down when I get solid state resistor. So, and as it goes down a degree, it increases the delay on the off state relay. So at the very bottom, at -5 degrees off the set temperature, the relay is on all the time. So as it comes up and gets closer, it turns off slowly and slowly until it gets to the set temperature. So it probably hover around in the middle, probably 3 degrees below the set temperature. But we'll just work that out. We'll just get there and change the program to suit. I think we'll mount this all on a board and have it on the bottom of the top of the case. So it's all together. Put an Arduino in here, a small one, and have the relay separate. And I'm going to make a hole, a 7mm hole for this. This is 7mm, but I'm going to use a soldering iron because to start it off with, so I can get it sort of roughly in the middle when it's warmed up. Right, lift it up slightly because I don't want to go through the middle, through the mat. So that's in the middle there, and we'll actually just. We'll make another hole for the LED. Where should we have that one? LED wants to be. Well, let's have it at the top. Yeah, I think that's a good idea. About there. Oh, right, we're going. Oh, that's not even in the middle. 7mm, 5mm. Right, best get Arduino. We could, there we are. Arduino Nano is it called? Is it? Could use a Pico at this stage. See if we could speed up that signal reading for the temperature sensor. We'll just go with one of these. Need one. Need to solder some bits on it. Oh bugger! I'll just solder some headers onto the bottom. Well, I've got it all assembled. Got an LED wired into digital pin F5 and hopefully it'll fit in the box. So there you go. We'll connect it up. Right, here we are on the test bench and I've had a few beers so I have to understand what I'm going on about. This button, I've wired the positive and the negative the wrong way around, so it should start in there at 60 degrees and then work up in temperature, so I'm going to have to change the program to do that. But here we go, look, I'll show you the temperature probe here is at room temperature, so this is set at 60 degrees, so when it gets hot, it should go out slowly, blink out, a bit more heat. Come on, here you go, look, so it's blinking out slowly, it's gone past 60 degrees, so it's gone up to 60, a bit more, and when it comes down in temperature, it should slowly just pulse on a little bit. There you go, so it's pulsing on now as it comes back in below 60 degrees, so it's going to try and stop the bang bang effect. So now it's dropped below 55 degrees, and it's on all the time, so as it comes up to 55, comes to 56, it'll come on for 20% at the time, 57, 40%, 58, 60 and 59, 80, and then 60 degrees it will go off completely. It's covered in lighter smoke. Anyway, so that bit's working. Just got to change it, put an equation into the program to turn it the way round. So back on the left hand side is this low scale, 60 degrees. It should come on soon, come on. Good, where are you? There you go, let's go bring it back down. You can drop it down to 60 degrees. There you go, perfect. Yes, it does. When it reads the analog pin, it comes out of an S value. That S is a value of the analog pin, 0 to 1023. So if we just put S equals 1023, sorry again, minus S, then it reverses the S result. So in fact, reversing the switch. Oh, it's a lot easier than unsoldering it and soldering it back again, especially with my eyesight. Right, I've got it all. I've got the wired in, but I've got the command in the computer the wrong way around. I'll show you what I mean. It's not coming on when this is on. That light should be on now. Just heat up a bit. Should be enough. There you go. Look, now that's coming on when it shouldn't do. So that's, I have to reverse all the commands round. And now you can see it swapping over as it cools down, and the heat comes back on again. Yeah, so when you're doing a solid state relay, it's the opposite way around on the functions in the computer. There you go, look, it's working. I've got the sensor above the bulb, so it's gone above 60 degrees, it's turned off. So the bulb's heating up the temperature probe at the minute, so hopefully when it comes back down it should settle down. There we go. Oh, is it settled down? This is what I mean, look. It'll be at a constant temperature now when it settles down. Well, that seems to be working perfectly. Let's wait for the bits to arrive now. So we'll see you in a week's time. If I take this away, look. Cool down, put it back. Ow! Yeah, I just burnt myself on here, that's what I went ow at. That's really hot, and it's only using 55 watts. It's supposed to go up to bloody 5 amps. Well, parts have started arriving. There's the aluminium 4mm plate. I know it's not cast and ground, but oh, this isn't coming off very well, is it? And I measured it, the weight, and it's 431 grams, and the computer said it was going to be 432, so it is probably right. Right. So some more bits have arrived through the post. Sticky on heater, 150 watts, 24 volts. A safety cut out fuse, 125 degrees centigrade, and a 3mm stud to cut up into 3 pieces for the bottom to screw onto the bottom of the printer base. Oh, and a heat gun, £8. To measure the glass when it's heating up. So I've marked a centimetre in off the corners, each corners. I'm going to drill them out to fit this size bar that I've got from my local shop, DIY shop, and it's I can't remember now, looks like 5mm, doesn't it? No, it's not on the label. Anyway, I'll measure that. Right, I punched all the holes where I'm going to drill them, and we're going to be using a 5mm tap, and that's 5mm when you twist it around, and you're not going to be drilling it out with a 5mm drill. You're going to be using 4.14 drill, because you obviously don't want to be drilling it out as wide as the tap, otherwise you won't put any threads on it. Because this plate is a top plate and we're going to be screwing them in and putting a lock nut on it, so it is fixed, because we don't want it poking out the other side. Now I've got the holes drilled. We're going to put the bottom plate on top, underneath, and mark it so it's exactly the same position as the other one. Okay, back when I've done. So now you shouldn't go wrong getting the holes in the right place. And I think I'm just going to put an arrow on there so we know which way round it goes, just in case it is slightly off. Oh, a bit too much. And then just because it's aluminium, you haven't got to really press it hard. Keep it straight and turn it around slowly, and it should guide itself in. And then keep going down till you've cleaned up all the threads, and back out again. Then I'm going to give it a bit of a clean off with some alcohol. Oh, that's too much. I'll see this tip on YouTube, so whether I'm doing the right thing or not, I don't know. Too late now. And then after you've done this, wipe it off with some tissue, IPA. Right then, 22.9 degrees. We'll turn it on. Right, she's turned on. I can smell hot things. 23 degrees. 23.2. I don't think it measures. I don't think it can measure metal very well, shiny metal. 24. Not buckled at all, so it's not too bad. It's still touchable. It wants to get the outsides warm, so I read my sensor. So how long that's been on? About a minute now, and it's still. It just says it's 23 degrees. Yeah, that must be 60 at least. Yeah, you can't touch that. Getting too hot. I might turn it off. Yeah, I'm going to turn it off. Don't want to melt it. I've tried the threads and it was knackered. Obviously I'm not very good at doing that. So I've counterbored the screw holes down. Put some screws in, sorry. So it's perfectly fine. Probably better, to be honest. It's more solid. Next part is to drill some holes in the back bracket. Yeah, so I've got both the bolts, both the plates connected together. There's still a bit of a gap I could close up if I've got some half nuts on there. But I've just sat this on the printer, and the height of the printer bed that I took off was 79mm from the base, and this one's 75, but we've still got 2mm of glass to go on there, so that's 77, so we've got 2mm to play with. So I've got to make sure this sits quite low on the arms, on the up and down arms. So we could still put 2 half nuts in there. I think there's about a mil or 2 we could play. We could also cut the bit out there where the heater thermostat is. Plus we've got to get this is the next job, because I can't get me where's my thing gone? Here it is. I can't really use it. I can. There's enough space so I can attach the thermostat, but I also want to try using this inbuilt thyristor temperature reader, so we can see if we can use that rather than using this. It might be a bit better. Oh, I've got to put the safety fuse in as well, as you know, there it is. So I've got to put that in there somehow. Right then, so we're looking at the thyristor or thermistor, so whatever it's called. So if I put my hand on this plate, I've got cold hands as well. It's 105k resistance. Just by putting my hand on this plate, it goes through the 4mm of aluminium and through the heater pad and to the other side to the temperature sensor thermistor. So it's definitely works. So I'm going to try and use a voltage divider, probably 110 or something. I don't know what I can't find out how to do it, how to work out the value. But you can see that it's definitely making a difference. So, good experiment for tonight. Right then, I've got the another Arduino set up to measure the thermistor. I'm using 220 kilo ohm resistor. I think I need to go a lot smaller because at room temperature I'm getting this is a thermistor wires coming in, and so this is 5 volts. This is going to the A0 pin. This is going to the earth. So you get a voltage divide across this wire here. When this goes low resistance, it puts a bigger voltage in there. So say we're starting at 6. I'll show you anyway. There's the readings coming in. So I'm just going to connect the power up. I'm going to turn the power on now, and you'll see the voltage. Well, hopefully you'll see a change. Yeah, there you go. So the heater's heating up now. So it's definitely working. Oh, is it? What's going on? It's going the wrong way. I thought it was going to go the other way. While the wires come out, I'm just going to try it again. What's it at? 740. So it's changing. And it feels, the plate feels, yeah, I'm just going to use the smaller resistor, see if that works. Okay, that's something experimenting for tonight then. So it's the next day anyway, next morning, and room temperature we're getting 675, so we're going to change the resistor. So we're going to go down to a 100k, see how that works. So that's brought the value down to 470, so we've come down quite a bit. I'm just going to go another bit lower on the old resistor, I think. I'm just going to touch this, see if it goes, how quick it takes to go up, because you'll get a better scale. Should have more of a scale now, but anyway, that's going to take ages. Let's go to the next resistor lower. 68k resistor, and we're on 380 thermistor. for room temperature. Okay, we're on the test bench. Oh, let's turn it on. Right then. 6 amps going into there, 24 volts. And we've got 420 on the... Oh dear, that's what's fallen off. What are we at? 500. 550. And the plate's starting to get warm. 600. 640. 700, just touched. Oh no, it's gone back down. There we go, 700. So I think if we do the range from 350 to 900, we shouldn't be too bad. Well, almost 1,000 actually. Right then, let's power up. 31 degrees. And I've got, oh, can you see that? Got that working slightly. It's out of focus at the minute, so I'm focusing on the thingy bob camera. So if you turn it up, the heat will come on more. And then turn it down. It's not perfect yet, but there you go. It is working. Look, it's just got two. I'm going to turn this up and see if it turns off. It's turning off now, look, so it's getting warm. And we're going to see what temperature this turns off at. So it's starting to turn off now. So we'll come and measure the 48 degrees, not very hot. 50. I suppose it is working. But this is trying to turn off now, so I'm going to have to adjust the program to make that work better. So another go. 56, nearly at the magic 60. Ow! 58. Ow, I want to turn it off, turn the power off because it's reaching what its target is. I don't want to melt it. 60, yeah. Oh, 60, sorry. Another go. Oh, that seems to work. Just gotta wait for get a solid state relay through the post. So I'll take the bottom plate off and we'll get some holes drilled for the so it can sit on the up and down bit, the Z table. Right, to do this bit, that hole there is obviously in the middle, so I put that in the middle of the plate and measured it. So it had 7mm off the edge of the heater mat, because that's roughly where the heater mat finishes. That's where the old bed finishes. That's where the travel is. So and then I couldn't measure, and I measured across here, and it's 10 centimeters altogether. So obviously I can find that easy enough. But then this one is a bit harder to measure because the hole's not lined up with these. So I come out with 13.6 centimeters from there to that bit there, and then you measure it across, don't you? So I've marked my holes out. I'll just put this on top to check, see if it roughly lines up. Go and drill them 3mm deep, 3mm wide. Right, got the holes drilled, and I've got a some metal rod, 3mm threaded rod. So I've got to cut that out to the appropriate length. But to test, see if I've got the holes in the right place, I just thought I'd place this on top of the jigging me for the old one. I'll back in a sec. And yeah, fits perfectly. Job done well. So I've got the three M3 bolts put into the thing, so it's reproducing these M3 bolts there. Look, I'll get a better shot there, don't you? So there you go. Look, there you go. Fantastic. It took me ages to find all the nuts, M3 nuts. Blimey. Well, I've got it mounted on. Trouble is the screws, the 3 screws going into the bottom aren't flexible, so they're quite stiff, so whether it'll adjust is another thing. But we're looking like we're getting there. I'll put the glass on next. Well, I've got this 3D printing, heated printing glass. It's got a mirror on one side and it's got a grey bit on the other side. Am I using the wrong side? Should I be using this side to print? I'm not an expert, I'm just winging it. Well, since I measured the we'll try a little what do you call it? Oh god, I'm drunk. Oh dear. We'll try and zero the head up onto the bed. Right, so I don't really know what I'm doing, but I'm going to put the level thing on there and hopefully the head will come up. Oh dear, what have I done? It's coming up now, hopefully it don't crash into the head. All the wires are out of the way. Did measure it, there should be enough room. Oh, yes. Nothing's broken. Is it in focus? So it looks like I have to press this there. So say I've done the unwind the buttons down, but I haven't done it. Just left them as they were. I've done one check already. So it's going to check the distance of the screw on the left hand side to set it up. Not say whether it's good or not. Congratulations, it's okay. So move on to the next side. This screw over here, there's 3 screws, that one there at the back. It's like waiting for an MOT for the car, isn't it? Quite nerve wracking. I've got to take it all apart anyway, set up again anyway, so it's not a big problem if it fails. Well, I reckon it's going to pass. If it does it twice, I think it's checking it again. I think it's good. Yeah. Level completed. Finish. Then we'll go to home position. So, good night really. Everything's happy. Just just wait for this solid state relay to come in, and then we'll be all ready to print and get Chris round. Okay, see you in the morning. Right, that time for the safety fuse. These are rated at 128 centigrade, so I want to stick one there, but I'm just going to try it out first. I'm going to power it up and see if it can survive. It's 10 amps and I'm using 6, so it should be alright. Well, it's working, so we'll stick one on with this thermal glue that I've got from my ZX Spectrum heat sinks. Hopefully it'll work alright. Okay, so I've drilled these holes to 5.5 to make them fit on a bit better. It does go on a lot better actually. And I've also got some washers because I was gouging up these holes. I don't know if you can see that on there. Oh god, it won't come off now, look at that. Yeah, I've got some washers because the nuts just gouging up the soft aluminium really badly. So that bit's all finished. Well, we might drill some holes in here actually, some cooling holes. And the glue's dried. This is quite strong to be honest. So I should have put the wires on first, but I'm quite happy it's quite strong, so I'll be able to solder them on alright now. So I'm going to cut one of these wires down here, put it into there as a fuse, and then put the other end on there. So that's a bit sorted. And as well, my solid state relay's arrived. 25 amps DC, up to 220 volts DC, and a 3 volt trigger to 32 volts DC. So that'll work off the Arduino. Oh, we're nearly there then. Right, I've just plugged the relay into the Arduino negative on there, and then this is the pin 9 I think it is. So we'll turn it on, and if this should come on at the same time as the green, yes. Sorry, you can't see that, can you? Same time as the green one. So we know I ain't got to change all the programming around. If I turn that around it should. No, anyway it's working. Yeah, it's flickering on at the same time, so that's perfect. So got the 24 volts turned on supply. It's not getting warm, so it's not shorting out. Right then, we'll plug in the Arduino and see how it works. This is on the lowest temperature setting. It's already starting to control itself. It just feels a little bit warm to the touch. Alright then, we'll turn it up. Let's go halfway. I'll come back in a minute. Okay, so it's kind of settled down. 41 degrees. 41.1 degrees. I'll come back in a minute, see if it's settled. Oh yeah, one of the main reasons I wanted to check this out is make sure it don't get too warm, because if it doesn't get too warm I can't put it inside this box, can I? I'll need to put a heatsink on the back. I might just put a heatsink on the back and leave it inside the box. Drill some holes in the box perhaps. It's not getting warm. But we'll see. Okay, it's been 5 minutes now. 44.7. 44.6, so that's pretty good. Let's go up a bit. Let's go up to see what that comes out at. Right, it's been 5 minutes. 51. 51. So I'm going to mark that down as the place on the dial. Well, bugger. Get the right bit. And then we'll turn it up, see what it can go to. Turn it on full power. So it's kind of settled down. It's not really settled down properly, but it's at 65. So I think we've got, that's at 62 at the minute. So it's obviously spreading out, but I think that's going to be a good enough range. 50 to 60. 66.6. I'm always getting loads of 66s in my life at the minute. Let's see if we've got 666 again. 667, you see. Okay, let's turn it down then and see what it cools down to. Well, it's taken a good 20-30 minutes to cool down. 31 degrees. I would have preferred a thermostat in there, and plus as well, this is a bit jerky. The readings aren't perfect. I think I'm going to put in the program, because the readings seem to be up and down, so I'm going to get 10 readings, add them all together and then divide them by 10 to get a rolling average over a second. Then that'll give a better reading. It should control it a bit better, because it's, even when it was turned down and it was hot up here, it was still clicking on every so often. But anyway, that's that bit finished. So I've worked out this will fit in there fine, and there'll be enough room for that to go in. And I've also made, out of a bit of old 22 copper millimetre pipe, made a heatsink. Just a bit too wide at the minute, or I can cut the notches out. Oh, we're going to tidy that up and make it fit anyway, and just drill it to the bottom of here, as so, onto that plate. And that should be enough to keep it cool. Bit shinier. I've got to snip out some bits, look, on the corners, and them 2 bits there to make it drop down. Drilled 4mm holes for the plenty of thermal paste on it on the back of the solid state resistor. Now, oh god, there's some crap on there. Look. Now put this on here, this way up, and we'll bolt it down. I'll see in a minute. It's squeezing out both sides, so we're alright. Right, got this all bolted down. 4mm bolts. Looking nice, isn't it? So that'll fit in there. Possibly drill a hole in the side and a hole at the back for certain ventilation. And now we've got to make the wires for there and there. That's all the soldering done, all the connections done for a minute, and then we're going to assemble the solid state relay in there now. Well, this should be ready to put together, look. 24 volts in the back, negative, positive. 24 volts goes up here to here, and then out the other side of the relay to the fuse on the heater. Then it goes to the heater, and it comes back into the negative pole there. And this is your negative ground connected to your Arduino, and this is the digital pin which controls the relay. I forgot which one it is. I think it's 9, but I don't think it is now. Anyway, I'll try and put it together now and see if it works. Well, she's all put together. I've got 24 volts coming in there. Ow! And yeah, it's 50 degrees. It's set to 50 degrees. Whether it is or not, I'm not bothered now. It's too late at night, so I'm going to finish off the back plate now. I'll drill some holes in that, and we're nearly done. Well, 2 hours later, I've nearly got all the holes drilled. Trouble is, it pushes a big burr out the back, and it stops it sitting flat on the. Oh, 9 more holes. I'll see you inside in a minute. Yeah, what I meant about all the crap coming out the other side. Look how much I need to deburr it with. I can do this one again. It's not going to do it any harm with the cooling. Oh. Nice job after a few cans. Well, not too bad. Look like someone drunk and done it. So I'm not blaming me. But it might be because I'm drunk and I can't see straight, because that looks a bit wonky. But anyway, we're not bothered, it's going underneath. No one's going to see it, just let heat through. So I'm going to put it together now. Okay, all put together. The screws are all the right length now. Looks quite nice, doesn't it, really? I'm quite happy with it. So what we're going to do now, install this in the machine then. Oh, I'll put the glass on and probably weigh it. Looks quite sexy. I'm going to weigh it now. Well, you can't see it, but it says 1,144 grams. I thought it was going to be 1,200 grams. Might be all them holes are drilled. So I think I'll do a final test with the glass on top and temperature test at 50 degrees. It's now 49 minutes past 9 o'clock at night. So we'll see what happens. What am I looking for now? Well, I can't, it might be kind of lager, to be honest. Oh, okay, we'll come back in a minute when it's warmed up. So I want to make sure the glass doesn't smash. Tell you what, mate, I'm fed up with this. I've tested it out and it worked. Now I've got it connected together. It's broken. It's not turning off. Bloody, I tell you what, these bloody things are a pain in the arse. And I unplug the Arduino and plug it back in again, and now it's working. Of course, the plates at can you see that? You can't, can you? The plate says 52 degrees, so it should start heating up again soon, which is now. So it's 49 on the edge. It says 53 over here. Let's just try and do another one. 48 over there. Why is it hotter on one side than the other? $50, 52 and 52. So it's better than nothing, isn't it? Well, I've left it 20 minutes. We've got 49 degrees. Well, that's perfect. 49 degrees. 49. Yep, so I'm happy with that. We can put it together now. So now to test the level. I've never printed a 3D printer off before, so I'm going to wait. I'm going to leave the video and finish it after this bit. Wait for my mate to come around and show me what to do. So here's a diagram, circuit diagram for you. Should hopefully be clear enough. I'm going to check if that is 100 ohms. I'm sure it is. Kilo ohms. That's adjusts the thermistor sensor output. So program will be in the comments. Thanks for watching.